we'll discuss about graded potentials in detail. The same thing, we draw a graph with membrane voltage on y-axis and time t on x-axis. We introduce a stimulus to the neuronal cell. That stimulus is not a threshold stimulus. That means the stimulus is not capable of inducing the threshold voltage. That means the voltage that we get from the stimulus is not the threshold voltage. The stimulus cannot get the voltage up to threshold level. It is a sub-threshold stimulus. That means the stimulus will get the change in membrane potential below the voltage level. That type of stimulus, we are considering three types of stimulus. 1, 2, 3. Okay. Let's say in the first case we have a in the first case we have a stimulus which strength is low and is of a lower duration. We obtain here the amplitude is low and the time duration of the graded potential is low. If we increase the strength of the stimulus, for example, there is warm water and there is too much of hot water. The strength of the stimulus is more in hot water than in warm water. Like that, if we increase the strength of the stimulus, then what will happen if in the membrane potential, the amplitude of the membrane potential will increase. And if we apply for the same duration, the duration will be same. If you apply the same stimulus for longer duration and if we increase the amplitude or strength, the amplitude and duration, both of the membrane voltage will increase. We get a high amplitude and a high duration. Okay. If say this graded potential or this change is this change is increasing the voltage up to threshold potential, then an action potential is fired. Okay. So here the amplitude and the duration, both the amplitude and duration vary with respect to stimulus. That is, the amplitude of the potential vary with respect to strength of the stimulus and duration of the potential vary with respect to duration of the stimulus. These are local changes. Why? Because these changes in potential decay over a certain distance. That means it can propagate from cell to cell, but after a certain distance it stops. Whereas the action potential, it propagates over the entire length of the axonal membrane, where graded potentials decays over a certain period of time. It only transfers up to certain cells. That's why these are called as local changes. Now if we see the definition, graded potentials are local changes in membrane potential whose amplitude and duration vary with respect to stimulus. These graded potentials are of two types: depolarizing potentials, hyperpolarizing potentials. If the producer graded potential induces or the graded potential causes a positive change in membrane potential, then the potential is called depolarizing potential. If the graded potential is of a negative change in the membrane potential, then the graded potential is called hyperpolarizing potential.